Okay, hi kids. We're picking up on 7.3 part 2 video, and we're discussing trig integrals and using a substitution with trig identities. So we're talking about the integrals of a sine to the ax, cosine to the bx dx, or the integral of tangent to the ax, secant to the bx dx. And we're going to use these helpful identities. So we left off, we talked about a few different things. Let me see, we talked about case one, at least one of the powers of sine x or cosine x are odd. We paired off one of the odds. And then we talked about how both of the powers can be odd, and we have to choose one. It's always going to be easier, though, if you let your du be cosine, because your u would then be sine x, and you wouldn't have to worry about that negative sign, but no worries. And now where we left off is we have the powers of sine x and cosine x are both even. So being both even, we have the cosine squared. So we're going to use what's referred to as the power reduction formula. You see it over here. We're going to take cosine squared and we're going to make it a linear function, if you will, just a cosine 2x. So you can use the double angle formula, like I said, for cosine to derive these power reduction formulas, but if you just memorize them, they're kind of easy to memorize. So with this, we're going to say we've got 1/2 factored out already. So I changed the cosine squared using the identity 1 plus cosine 2x over 2, factored the 1/2 out. So now I just have the integral of 1 plus cosine 2x. So I could distribute this, or distribute the 1/2 and then split the integrals. I'm going to leave it as a 1 dx, if you will, and then plus a 1/2 and then the integral of cosine 2x dx. So then I have the integral of 1 dx. It's just going to be 1/2 x plus, and then I have the 1/2. Now you have to be careful, but remember when you integrate cosine 2x, that's going to take you back to sine 2x, but you're going to have to divide by 2 or multiply by another 1/2. So it'll be sine 2x and then plus c. So our final answer then would be, our answer to the integral of cosine squared x dx would then be 1/4 x 1/2 x plus 1/4 sine of 2x and then plus c. There you go, there you have it. Okay, so using the power reduction formulas. So we have a case where we want to find the antiderivative when both sine and cosine are squared. So we're going to use the power reduction formulas for both of them. And so you can see that I have them up here, where I always remember that the cosine is positive and the sine is negative, the sine joining the 1 minus the 1 plus cosines. So now you've got the difference of two squares you can employ. So we can factor out the 2's that we have in the bottom. We can pull that out as a 1/4 then. So we have the integral of 1 minus cosine squared of 2x. And so what I'm going to do is split the integrals. You have to remember the 1/4 has to be distributed to both integrals. So now I have 1/4 x, because that's the integral of dx. And then I have minus 1/4 times the integral of, now I've got the power reduction formula for cosine squared 2x. So if you just take a second, say cosine squared of 2x is equal to 1 plus cosine of 2 times 2x over 2. So it's going to be a 4x for the angle. Okay, so now I'm ready to switch things up with this and say, okay, I'm going to factor the 2 out. So let me see if I can fit this in down here before going up. I have 1/4 x, and then this is going to be a minus 1/8 times the integral of 1 plus cosine of 4x dx. Like that. Okay, so now I could really go straight ahead and integrate. Let's see how this goes. So I'm going to have the integral of 1 plus cosine 4x. Remember, when you get to the cosine, you're going to have to divide by 4, but the integral of cosine is going to be sine. So let's see how it goes. So I have a 1/4 x out front 1/4 x. I'm going to put equal 1/4 x, and then I'm going to have a minus 1/8 x, and then I'm going to have another minus that's going to be distributed. And you have to be careful. You already have a 1/4 that you have to multiply by in the first case, but I've factored out a 2, so now it's made it a 1/8. So I have a 1/8 x, and then it's going to be minus, I'm going to do it like this, minus 1/8 times the integral of cosine 4x dx. There's like too much going on there, so we want to take our time with it. 1/4 x minus 1/8 x is just going to be 1/8 x. And then I have the minus 1/8, so it's going to be minus 1/8. And then you're going to have to divide by 4 and integrate the cosine 4x. You get sine 4x. And then it's going to be plus the arbitrary constant. So my final answer here, I'm going to put a star here. I've just got too much writing going on here. So it's 1/8 x. And then I've got 1/32 sine 4x here plus c. There you go. There you have it. There it is. Okay. And let me see if I can fix that box up there. And that should be the answer for my integral then. Okay, so there's number 5. Number 6, so that was where we were using the power reduction formula for both sine squared and cosine squared. Now we're going to move on to the powers of tangent and secant x. So where we started off with the du with the sine and cosine integrals, we're going to do the same thing here. But remember, du it should probably be differentiable, so that I know that my u, if stated, is going to have that du. For instance, du is equal to secant squared. Therefore, u has to be tangent here. And then if du is secant tangent x dx, then u will be secant. Okay, so what we're going to do then is, again, du should be selected so that the integral can be rewritten in terms of u using the identities without taking square roots. You don't want to take square roots. So we start off pretty easy, and I look and I see that I have a secant squared here. So I'm going to state my du is secant squared. I'm going to say my u is going to be tangent then, going backwards. So I end up with the integral of u squared du, so that'll just be u cubed over 3 plus c, and then my answer then would be tangent, because u is tangent. Tangent cubed x over 3 plus c. And there would be my antiderivative. And these are indefinite antiderivatives, or indefinite integrals or antiderivatives. So we have to have that arbitrary constant there. Okay, now you might think, since we have secant and tangents, you don't want to make du equal to secant tangent in this one, because you're going to end up with square roots somewhere. So better off if you just use the secant squared here. Okay. So next one. Okay, so on the next one, I did a little bit of prep work on this one so we could get through it a little quicker. But I see that I have odd powers of secant and tangent. So I'm going to pair off a secant tangent, so that's one of each of them, so that I can have this balance of secant squared and tangent squareds that interact well together, because we know that if I pick my du and then my u is going to be secant, I can take and use tangent squared plus 1 is equal to secant squared, so then the tangent squared is equal to secant squared minus 1. So that's what I'm doing. I'm taking the tangent squared here. Probably a different color would be better. So if I take the tangent squared here and replace it with secant squared minus 1. Okay, so now what we're going to do is we're going to say, all right, we've got our du. My u's I've got in place. So now I'm just going to put the u's in. I've got u squared minus 1 times u squared times du. And now what I can do is go ahead and distribute, so that'll give me the integral of u to the fourth minus u squared du. And now I can integrate, take the antiderivative. I got u to the fifth over 5 minus u cubed over 3 plus c. So now I'm going to back substitute and put in my u. My u is secant. So I end up with, and I like to state the answer, but I think for right now I'm just going to say this is equal to then putting the secant in. So I have secant to the fifth power over 5 minus secant to the third power over 3, and that would be plus the arbitrary constant c. And here's my antiderivative. Okay, see how that works for you? Now, there are times when you have a choice, okay, that sometimes you can have your du be one thing or another, and you can get equivalent answers. So now, I need a mix of tangents and secants, and all I have is a tangent cubed here. So I have to stop and think, what do I want to do? So I look at this and I think, all right, well, I'm going to split the tangent cubed as tangent squared and tangent. And then I could take the secant squared minus 1 and replace the tangent squared. So now using the identity, because recall that tan squared plus 1 is equal to secant squared. Now I'm going to distribute the tangent. So then now I have the integral secant squared x tan x minus tan x dx. I'm then going to split up the integral. I'll split up the integral so that I have two integrals instead of one. I've got secant squared x tan x dx minus the integral of tangent x dx. Now, remember that the integral of tangent x is equal to the integral of sine x over cosine x. And you can use a u sub with that, a regular u sub. And you could say, well, u is equal to cosine x, and then du is equal to negative sine x dx. So you could actually change this. Let's put a dx here just so it makes sense. So negative du would equal sine x dx. So you can do a simple one. If you don't remember it, you're going to end up with the integral of 1 over u du form. So it works out pretty nicely. If you don't memorize this, I just, every once in a while, I would just go back to using sine and cosine. But you can do either. Memorize it or go back to sine and cosine and do a u sub. So here we have secant squared. So now in this one, I'm going to say my du is going to be my du. In fact, I'm going to change the order of this right now. I'm going to switch this, pull this out. I'm going to put this up front. I'm going to put the secant squared here with the dx. So it's convenient. So I can see that my u is going to be tangent. So my du secant squared x dx, and my u then will be tangent x. Okay, so I end up with this beautiful little, the first one is just going to be u, the integral of u du, and that's easy because I'm going to finish that one, then go back. That's just going to be u squared over 2. Okay, now they're different u's, so you have to be careful with what we're doing here. So then I have this minus, and I have the integral of tangent. So I know that's the ln of cosine x, but it has to be the absolute value of cosine x. And I'm going to put a plus c here on the end. So I have the integral of ln of times the absolute value of cosine x plus c. So I'm going to take one more step. I've got to put my u. I didn't bother using the u sub with this tangent because I thought I've already got a u sub going on the other side, and it's easy enough that the integral of tangent x is just ln of cosine x. So now I'm going to back substitute my u. So I end up with tangent squared x over 2 minus ln of the absolute value of cosine x plus c. Oops. Plus c. And there you have it. There is my antiderivative for the problem that you see up here. Okay, and then we have another one, secant to the fourth. Secant to the fourth, I'm going to split up the secants. When I split up the secants, remember you want to mix the tangents with the secants. So what I'm going to do is I'm using the identity for the one secant squared, leaving the other one there. But now I'm going to distribute the secant squared. Let me just think for a second. I could actually say u is equal to tangent, and at this point I really don't have to distribute here. Different ways that you can approach these problems. So I'm going to make this, I'm going to put the u in now. I've got u squared plus 1 here, and then I've got a du here. So I'm integrating u squared plus 1, right? Let me just think for just a moment. Okay, so now I'm going to integrate, so I get u cubed over 3 plus u plus the arbitrary constant. Now I'm going to back substitute because my u is equal to tangent. So I end up with tangent cubed x over 3 plus tangent x plus c, and there's my antiderivative. I'm going to try to finish up this last problem. It's kind of a cool problem. I'm going to use integration by parts with this. So I'm going to look at this problem. I'm going to say, all right, it's got an extra secant here, and I don't have secants mixed with tangents, so I'm going to try integration by parts. And so I have the integral of u dv is equal to uv minus the integral of v du. So I hope you can see at this point that I use my u is equal to secant x, easily integrable. They're both trig functions, so I have my choice. However, the secant squared is integrable, right? I want to kind of take this table and go like this here. So my dv, I'm going to use this region here. So my u is going to be secant x, and my dv is equal to secant squared x dx. Now remember, we're integrating here, and we're going to integrate there just to get the v, and we're going to take to get the u. Du is going to be secant x tan x dx. So we have that. This over 2. Ooh. So then when we integrate, we get v is equal to tangent x, right? So I have integration by parts all set up here, so ready to go. So now I have uv, so I have secant x, and then v is tan x, minus the integral of tan x times secant x tan x dx. Okay. So on the left-hand side of the equation, what I'm going to do is I'm going to replace that with secant cubed. Okay, so I've got secant cubed x dx on the left is equal to, So it's secant x tan x, and then it's minus. So what am I going to do here? I'm going to make this a tangent squared. So I have the integral of tangent squared x secant x dx. I've got to mix up the secants and tangents, but I don't really have the right mix. If u is secant x dx, then du is secant tan. And I don't have the right combination there. I'm going to have leftover tan, or I don't have a secant squared, right? So what I'm going to do is I'm going to change the tangent x. I'm going to keep writing this. Secant cubed x dx is equal to secant x tan x minus the integral of secant squared x minus 1. And then that's going to be times secant x dx. So now what I want to do is continue downward. So I'm going to change everything. So I end up with the integral of secant cubed x minus secant x, still dx, right? Just distributed there. And that's interesting, right? So we have the integral of secant cubed x dx, and this is similar to one that you have dealt with recently, secant x tan x minus the integral of secant cubed x plus the integral, dx here, forgot the dx, plus the integral of secant x dx. Now there is a little trick when you do the integral of secant, but it's not really that big of a deal. We can get to it. You simply take this integral, the secant, and you're going to multiply the top by secant x plus tan x over itself. So I'm going to ask that you look that up. You'll probably see it in a gradient secant method. Okay, and that's what you're going to do. So if you use a u sub, the denominator is secant plus tangent. The numerator is going to end up being secant squared, secant times secant x is secant squared, plus secant x times tangent is going to be secant tangent. So the u is in the denominator, you're doing a u sub with an ln. Okay, so here's what you get. We're going to add this one, secant cubed x, to both sides. So the left-hand side, integral of secant cubed x. So the left-hand side is going to be 2 times the integral of secant cubed x dx is equal to secant x tan x. And then it's going to end up being plus ln of the absolute value of secant x plus tan x plus c. And then you just have to multiply everything through by 1/2. So the integral of secant cubed x dx is equal to 1/2 times secant x tan x plus ln, and I'm going to put it in one whole parenthesis, of the absolute value of secant x plus tan x plus c. And that is all she wrote. So I hope this helps you get through this lesson, and I will see you when I see you, and have a great day. This is Allenator out. Thank you so much for your help with all the tutoring and volunteering in class. You guys are awesome. Okay, so this is lesson 7.3 on trig integrals and part 2. And so have a great day. See ya.